In today's video, we will be learning about the chemical kinetics. The word chemical is for the chemical reactions, and the word kinetics is taken from the Greek word kinesis, which means movement. So basically, the term chemical kinetics, so the definition for the chemical kinetics is the branch of chemistry which deals with the rate of chemical reaction. The chemical reaction is represented as reactants that are changing into the products. So we can just represent the reactants with R and the products with P. We know with time the reactants are being consumed and products are being formed. At 0 seconds, we know there is no chemical reaction occurring, so there is no change in the concentration of the reactant or the product. We can denote the initial concentration of the reactant as R1 within the square bracket, and the square bracket shows us the molar concentration, and here we have taken only 1 mole of reactant and 1 mole of the product. Similarly, the concentration of the product is taken as P1. Now, after some time, the reaction will start happening and the concentration of the reactant will change. So does the product concentration. So we can assume the reactant concentration as R2, and for the products we can consider it as P2. So change in the concentration of the reactant can be represented as R2 minus R1. Similarly, for the product, it can be represented as change in the concentration of the product in certain period of time, that is T2 minus T1. R2 will be less than that of the R1 since the reactants are being consumed and we know the products are getting formed, so that means P1 will be, initially it will be less, but after a certain period of time, as a chemical reaction happens, the concentration of the product increases. So the rate of chemical reaction can be written as decrease in the concentration of the reactants with change in time. Also, whatever the concentration is being changed in the reactant, that will also help in the formation of product on the other side. But for the product we have to write the positive sign since the concentration of the product will increase. So it will be written as P2 minus P1 with change in time. So we can write in short notation minus delta R upon delta T, which is also equal to positive delta P over delta T. So this is the formula for the rate of chemical reaction. We can represent y-axis, then x-axis. On the y-axis, we are taking the concentration of the reactant, and on the x-axis, we are taking the change in time. Since the concentration of the reactant is decreasing, the slope will move downwards, and with time for the products, the slope will move upward. The reason is the concentration of the product is increasing. To elaborate this process, let us consider we have the initial concentration of the reactant R1. With time T1, as the reaction will proceed, there is decrease in the concentration of the reactant, and we can consider this as 3 moles. And this will take a certain time. We are considering the time T2. This is how the slope goes in the downward direction. Similarly, we can look for the concentration of the product. We know the initial concentration of the product is 0. Until and unless the reactants are not being consumed, the products are not formed at the initial stage. But as soon as the reaction happens, the number of moles for the product keep on increases. Let us consider it is 2 mole. After some time, it will be 3 moles. Then it will be 4 moles. Then further, it can be 5 moles. Once 5 mole of the product is formed, it indicates that the complete reaction has happened, as we have taken the 5 moles of the reactant. And we know each concentration of the product has its own time lapse. So we can consider it as T1, T2, T3 until and unless it is formed. So we see that the concentration of the product keeps on increasing as the reactant moves further. So the direction of the slope is towards the right side in the upward direction.